Hello everyone, welcome to Miss Lee's class. Today we're going to learn how to interpret and sketch graphs. Look at the warm-up question. So, a graph provides much information. So we're going to look at the graph and interpret the situation. Okay, so this graph shows the depths of a scuba diver as a function of time. So as the time increases, the depth has been changed, right? So before we start, what we have to look at is the scale. So 1 unit, 2 unit is 4 minutes. Well, what about 1 minute? 1 minute is how many minutes, everyone? 2 minutes, right? 1 unit is 2 minutes. And 1 square, 1 box is how many meter, everyone? So 1 unit here is 2 meter. So each box here, 2 minutes and 2 meter. Okay, so remember the scale. First question: how many minutes did the dive last? Okay, so starting from 0, the dive ends at 30. Right? 1 unit is 2 minutes, so 28 and 30. So we say 30 minutes. At what time did the diver stop her descent? If you look at the graph, the diver stopped her descent twice. At 12 meter, she stopped her descent for 4 minutes, 4 to 8. And at 20 meter, she stopped her descent for 4 minutes again, 10 to 14. So we say at 12 meter, she stopped her descent from 4 minutes to 8 minutes, 4 to 8 minutes. And at 20 meters, 10 to 14, she stopped her descent from 10 minutes to 14 minutes. Okay, what was the greatest depth the diver reached? For how many minutes was the diver at that depth? Okay, the greatest depth is 20 meter. And for how many minutes? 4 minutes. So 4 minutes. Okay, so this is how you interpret the situation using the graph. Okay, here's another example. The properties of a graph can provide information about a given situation. So here, okay, look at this graph. Before we start, you always think about the scale. So scale for the dependent variable, scale for the independent variable. So this graph is telling you the distance over time. So distance from home over time. Okay, so the scale, 1 box. So 1 box is 1 minute horizontally, and 1 box is 1 meter vertically. All right? Okay. And say your distance from home is 5 meters initially, and as the time increases, the distance from home is increasing. So you're moving forward, and the distance is decreasing. So you're going back home, and the distance stays the same. That means you're stopping, and again, the distance increasing. That means you're moving forward, and then you're going home at a steep decrease. This is a very steep decrease, so you're moving fast. Okay? And so you're going back home at a moderate speed here. And the distance becomes 0. That means you arrived home. Okay, so this is how you interpret the situation, a given situation, using a graph. Okay, let's move on. Here, example 1. Each point on this graph represents a bag of popcorn. Explain the answer to each question below. Which bag is the most expensive? The most expensive. So vertical axis is the cost, and horizontal is mass. So here, the most expensive, C is the most expensive, and that is $7, right? $7. And which bag has the least mass? What is the mass? That is B, and the mass is 500 gram. Here, this is 500 gram. So you have to look at the scale again. Each box is 200 gram and $1. Okay, so here half box is 100 gram. So therefore B is 500 gram. Which bags have the same mass? What is this mass? D and E. D, E, and that is 1,800 gram. Which bags cost the same? What is this cost? A and E. And the cost is $4. Which of bags C or D has the better value for money? C and D. Which one is better? Which one is better by? If you look at D has more popcorn than C, but it costs less. Therefore, D is the better buy. Okay? Example 2. Describe the journey for each segment of the graph. Okay, so distance over time. So it's the distance between Winnipeg and Winkler is 1,030 kilometers. So day trip from Winnipeg to Winkler. So you're departing Winnipeg, and you arrive Winkler, and you come back. Okay. So if you look at OA, the graph goes up or down? The graph goes up. So we say the graph goes up. That means as time increases, the distance from Winnipeg increases. So for how long? How many hours is this? For the first hour, right? OA for the in the first hour, the car leaves Winnipeg and travels about how many kilometers? Travels about how many kilometers is this? So again, we have to think about the scale. So one box is 30 minutes, 0.1 hour. And one box vertically is 20 kilometer. So therefore, this is, I guess it's a like quarter box. So I would say that is 65 kilometer. About 65 kilometer. Winnipeg and travel about 65 kilometer toward Winkler. Okay? And AB, what's happening here? The graph is horizontal. That means as the time increases, the distance stays the same. Okay? Then as time increases, the distance stays the same. That means the car is moving forward or stopping or moving backward. The car is stopping. Car stops for about how many minutes? So one box is half an hour, but it's a half box. That means 15 minutes, right? Stops about 15 minutes. The car might be fueling, so we can say for fueling. And B, C, the car is moving forward again. The graph is going up. The graph goes up as the time increases, the distance from Winnipeg increases. Okay. For how long? So it's a little 1 box and half box. That means it's 45 minutes. For the car was moving for 45 minutes. For how many kilometers? From here to here. So this is about 130 and this is 65. Then for about another 65 kilometers, the car was moving forward for another 65 kilometers. Okay, so here we say for the next 45 minutes, the car traveled 65 kilometers toward Winkler. C and D. CD. Look at CD. The car is stopping. Right? The graph is flat. The car is stopping. So we say the graph is horizontal. The car stays the same. Okay, so in total, the car traveled 130 kilometers from O to C point. So the distance between Winnipeg and Winkler is 130 kilometers. That means the car arrived at Winkler. So we say the car has traveled 130 kilometers for 2 hours, and it reached Winkler, where it stops for 2 hours. Look at this. So the car stops for 2 hours here, right? And the car goes back home. The car didn't stop at all. From Winkler to Winnipeg, the car straightly went back home, right? DE. The graph goes down. As time increases, the distance from Winnipeg, because it's going home, the distance from Winnipeg decreases. Okay, so the car is returning home for 2 hour. 2 hour. And we know it's 130 kilometer. So we say the car returns to Winnipeg and it takes 2 hours to travel 130 kilometers. Okay. Alright, so do you guys understand how to interpret a graph? So using a graph, you should be able to interpret the situation, right? Alright, next question. Example 3. Samuel went on a bike ride. So we're going to draw the situation this time. Okay? So what we're going to do is we're going to read the sentence and we're going to draw the graph on the grid here. Okay? So let's read the situation first. He accelerated until he reached a speed of 20 km per hour. Then he cycled for 30 minutes at approximately 20 km per hour. Samuel arrived at the bottom of the hill and his speed decreased to approximately 5 km per hour for 10 minutes as he cycled up the hill. He stopped at the top for the hill for 10 minutes. So what we're going to do is we're going to decide the scale first. So what I'm going to do is I'm going to read the numbers given here. So his maximum speed was 20 kilometer. Okay? So his maximum speed is 20 kilometer. And the time, horizontal, time here 30 minutes, 10 minutes, and 10 minutes. So it's about like less than 1 hour. We can think about the horizontal axis, and the maximum value on the horizontal axis can be less than 60, right? So what I'm going to do is I'm going to let 1 unit 2.5, then 2 units becomes 5 km per hour, 10, 15, 20. Because the maximum speed is 20 kilometer, so this is good enough. And the time, I'm going to let 1 unit 5 minutes, then this becomes 10, 20, 30, 40, 50, and 60. Right? Okay. So what I'm going to do is he accelerated until he reached a speed of 20 kilometers. So say he accelerated for about 5 minutes. It didn't really say for how long he accelerated, but I'm just gonna use 5 minutes. Then here to here. Becomes like this. And then he cycled 30 minutes at approximately 20 kilometers. So 10, 20, 30, 10 minutes, 20 minutes, 30 minutes. And Samuel arrived at the bottom of the hill. Then his speed should be dropping quickly. And his speed decreased to approximately 5 km per hour. So drop the speed 5 km per hour. And for 10 minutes, as he cycled up the hill. So he's going to just stay at 5 km per hour for 10 minutes. Now after that, he stopped. Once he reached at the top, he stopped. His speed becomes 0 and rest for 10 minutes. Okay? So here, this is the first, second, third, fourth situation. So this is 1 first segment, second segment, 3 here, and 4 here. So does everyone understand how to do this? Okay, discussion. For a graph of distance as a function of time, what does each segment represent? So if the graph is distance over time, let's think about the situation. Okay, if it is a horizontal line, that means your distance does not change. That means you're stopping, right? Stopping. A segment that goes up, that is, you're moving forward or backward. Moving forward. And if the segment is decreasing, goes down, that means you're returning. So this is distance versus time graph, but distance versus, speed versus time graph is different. So as you see, this is a speed versus time. But before this was distance versus time, right? So if it is a speed versus time, horizontal segment, as the time increases, speed is the same. That means you're moving forward at a constant speed. So moving, you're not stopping, right? Since if you just continue going at the same speed, that doesn't mean that you're stopping. So you say moving forward at a constant speed. A segment that goes up to the right, that means your speed is increasing. That is, you're accelerating. And a segment that goes down to right, that means you're reducing your speed. That means you're slowing down. Okay, so we learned how to interpret a situation using a graph. So that is it for today, everyone. Now you can start your homework. Thanks for watching, everyone. Bye.